Now let us look at question number 10. The structure of PCl5 in solid state is. See, first of all you must be thinking, sir, why these structures are changing in solid and liquid phase. See, PCl5 is trigonal bipyramidal. It has already been asked in the exams that are all the bonds having equal strength in PCl5? The answer is no. Fine. See, you have got the equatorial bonds and the axial bonds, right? The equatorial bonds are stronger as compared to the axial ones. In the solid state, you want a strong lattice, so you want the equal bond strength. That is why this PCl5 exists as PCl4 plus and PCl6 minus. See, this is sp3d hybridization, whereas this is sp3 and this is sp3d2. So, this is tetrahedral, this is octahedral, all the bonds are having the same bond strength, right. So, the correct answer would be that it is existing as tetrahedral PCl4 plus and octahedral PCl6 minus. So, the correct option is option number 1, right. Now, let us look at question number 11. The increasing order of the acidity of the alpha hydrogen of the following compounds. See, in case of carbonyl compounds, the alpha hydrogen is considered to be acidic as the enolate ion formed is stable. But if there are some other groups attached to it, the stability may change. So, first of all, let us start with the compound A. See, this carbon is having the hydrogen. When you remove out this hydrogen, this carbon will be behaving as a carbon ion, right. Now, this carbon ion, as I am saying, is stabilized because of the formation of this enolate ion. A double bond between this carbon and negative charge on this oxygen. Higher the stability, more is the acidic strength. Now, you look over here in case B, this carbon having a negative charge, as you can see, it is stabilized on both the sides, right. So, this carbon ion is the most stable. As a result, this one will have the strongest alpha hydrogen out of these compounds. What about the oxygen and nitrogen? Aren't they stabilizing or they are destabilizing? See, over here, suppose this carbon is having a minus charge, right, because it has lost the hydrogen H plus. Now, this oxygen will share its lone pair, will show a cross conjugation over here, right. Similarly, nitrogen is also showing this cross conjugation over here, okay, which will actually destabilize this carbon ion, okay. Now, nitrogen is having a higher tendency to show this cross conjugation. As a result, the carbon ion in case of D will be the least stable out of these four, okay. So, what should be the right order? B is the most stable, followed by A, then because of cross conjugation C and D are less stable, but C is comparatively more stable as compared to that of D, because oxygen is having lesser cross conjugation capability as compared of nitrogen. So, the correct option should be B followed by A followed by C followed by D. So, B followed by A followed by C followed by D, right. So, the correct answer is option number 4. Now, let us look at question number 12. Which of the following derivatives of alcohol is unstable in aqueous base? See, this is ester, this is ether, this is also ether, this is also ether. As you know very well that the ester on hydrolysis will convert to alcohol plus carboxylic acid, okay. So, first should be the right answer. This is the most unstable in an aqueous base. Base will actually catalyze the reaction, okay.